Hey everyone, welcome back. Before we journey to one of the most eerily Earth-like yet utterly alien worlds in our solar system, I'm sending out huge virtual hugs and the very best wishes to all of you watching. Seriously, wherever you are in the world, I genuinely hope you're feeling fantastic, taking amazing care of yourselves, and staying healthy. That's the foundation for appreciating the incredible wonders out there. Now, grab your imaginary parkas because we're heading to a place where the temperature plunges to a bone-chilling minus 180 degrees Celsius, minus 290 degrees Fahrenheit. The air is thicker than Earth's, the sky is a hazy orange, and rivers flow into vast, shimmering lakes and seas. But here's the kicker. Those lakes and seas aren't filled with water. They're filled with liquid methane and ethane. Yep, you heard that right. We're talking about Titan, Saturn's largest moon, a frozen world where the familiar water cycle we know is replaced by a bizarre, frigid hydrocarbon cycle, making it the only place beyond Earth known to have stable liquid bodies right now on its surface. It's like looking into a funhouse mirror version of our own planet, where the rules of chemistry and physics play out with completely different ingredients, creating landscapes both hauntingly familiar and profoundly strange. Imagine stepping onto Titan. The first thing you'd notice is the thick, soupy atmosphere. It's about 50% denser than Earth's at sea level and mostly nitrogen, just like ours. But that's where the similarity ends. Instead of oxygen, Titan's air is packed with methane and a smog of complex organic molecules, giving the sky that perpetual orange-brown haze that hides the surface from visible light. Sunlight is incredibly weak here, only about 1% as strong as on Earth, filtering dimly through this haze. The ground beneath your feet wouldn't be rock or soil as we know it. It's likely a mixture of water ice as hard as rock, coated with layers of organic gunk that have rained down from the atmosphere over billions of years. And then you see them, expansive bodies of liquid, dark and smooth, reflecting the hazy sky. They look like lakes or seas you might find on Earth, nestled in depressions, carving valleys, filling basins. But if you dipped your hand in, well, a heavily insulated robotic hand, you wouldn't get wet. You'd be plunging into a pool of liquid natural gas. Methane, CH4, and ethane, C2H6, which are gases here on Earth at room temperature, exist as liquids on Titan's cryogenically frozen surface, behaving just like water does on our world. So, how do we know this? How did we discover lakes of liquid methane on a moon over 1 billion kilometers away? The hero of this story is the incredible Cassini-Huygens mission. Launched in 1997, the Cassini spacecraft arrived at Saturn in 2004 and spent over 13 years revolutionizing our understanding of the ringed planet and its moons. Titan, shrouded in that impenetrable haze, was a prime target. Cassini was equipped with a special radar instrument that could pierce right through Titan's thick atmosphere and clouds, bouncing radio waves off the surface and creating detailed images, essentially giving us X-ray vision for this hidden world. What Cassini's radar saw was nothing short of astonishing. Starting in 2004, it began revealing dark, incredibly smooth patches near Titan's polar regions. These patches had the radar signature of liquid, very dark, meaning radar absorbing, and extremely smooth, meaning the radar signal reflected cleanly back like a mirror. They looked exactly like calm lakes or seas. The biggest, Kraken Mare near the North Pole, is estimated to be larger than Earth's Caspian Sea. Others, like Ligeia Mare and Punga Mare, are also vast. Smaller lakes dot the landscape, some filling craters, others sitting in steep depressions with what look like river channels flowing into them. Near the South Pole, a large lake called Ontario Lacus was also discovered, showing evidence of shrinking and expanding with seasons, much like salt lakes on Earth. But Cassini didn't just see static lakes, it saw a dynamic world. Radar images taken over time showed shorelines changing. Some areas looked like mudflats exposed as liquid levels dropped, just like water receding on Earth. Dark channels snaked across the landscape, clearly carved by flowing liquid draining into the lakes. Some channels were steep and canyon-like, suggesting powerful flows, while others were more meandering. This was the smoking gun, evidence of active erosion, transportation of material, and filling of basins by liquid. Furthermore, Cassini detected specular glints, mirror-like reflections of sunlight off extremely smooth surfaces, precisely where the radar saw lakes. It was like seeing sunlight glinting off water on Earth, but on Titan, it was sunlight glinting off liquid methane. The combination of radar darkness, extreme smoothness, changing shorelines, river channels, and actual sunlight reflections left no doubt. Titan has stable liquid on its surface, and that liquid is primarily methane and ethane. This discovery led scientists to realize Titan has a full-fledged hydrological cycle, but instead of water, it's a methane cycle, or more broadly, a hydrocarbon cycle. Think about how water works on Earth. The sun heats liquid water on the surface, oceans, lakes, causing it to evaporate into water vapor. The vapor rises, cools, condenses into clouds, and eventually falls back as rain or snow, replenishing the surface liquids and flowing through rivers. Titan's cycle works the same way, but with methane as the star player. The weak sunlight provides just enough energy to slowly evaporate liquid methane from Titan's lakes and seas. This methane vapor rises into the atmosphere. Up there, it cools and condenses, forming methane clouds. Cassini and Earth-based telescopes have actually observed these clouds, particularly clustering over the polar regions where the big lakes are. Then, just like on Earth, it rains. Methane rain falls from the Titanian clouds. This rain carves the river valleys and channels observed by Cassini's radar and the Huygens lander, and it replenishes the lakes and seas. In the colder polar regions, especially during the long winter, some methane might even fall as snow. Ethane, being less volatile than methane, harder to evaporate, is less involved in this active cycle, but is a major component of the larger seas and accumulates over time. This cycle makes Titan the only world besides Earth known to have an active, complex weather system driven by evaporation, condensation, and precipitation involving surface liquids. The Huygens probe, which hitched a ride with Cassini and parachuted down to Titan's surface in January 2005, gave us an unprecedented ground-level view. As it descended through the thick, orange haze, its cameras revealed a landscape shockingly reminiscent of Earth. Hills, drainage channels, shorelines, and what looked like a dried-up riverbed or lakebed. It landed on a dark, flat plain littered with rounded ice pebbles, smoothed likely by the flow of liquid methane in the past. Huygens didn't land in a lake, but its instruments sniffed the atmosphere and confirmed high methane humidity near the surface, consistent with recent evaporation. Its images provided crucial context for the orbital data, showing the results of the liquid flows Cassini saw from above. It was like getting a postcard from an alien shore, confirming the liquid-carved landscape. Why is finding liquid methane lakes on Titan so incredibly significant? It goes far beyond just being a cosmic oddity. Firstly, liquid is a crucial ingredient for life, as we understand it. While Titan's surface is far too cold for liquid water, water ice is as hard as rock. The presence of any stable liquid solvent opens fascinating astrobiological possibilities. Methane isn't water, but it is a solvent. Combined with the complex organic molecules constantly raining down from Titan's atmosphere and the energy sources available, like sunlight breaking apart molecules or potential geothermal heat from below, Titan possesses a unique prebiotic chemistry laboratory. Scientists wonder if exotic forms of life, fundamentally different from Earth's water-based biology, could potentially exist in Titan's methane lakes or in a potential subsurface ocean of liquid water, which is strongly suspected to exist beneath the icy crust. Titan offers a chance to study the chemical steps that might lead to life in a completely different environment. Secondly, Titan is a natural laboratory for understanding planetary processes. Studying its methane cycle helps us model how volatile substances move and interact on planetary bodies. It shows us how erosion, weather, and climate operate with different materials and under vastly different conditions. Understanding Titan helps us better interpret data from exoplanets with thick atmospheres. Thirdly, Titan is just astonishingly Earth-like in its geological complexity, despite the alien materials. It has dunes, made of organic sand, not silica, mountains of water ice, possible ice volcanoes, cryovolcanoes that might spew water ice slush or ammonia, and of course, its rivers, lakes, and seas. It demonstrates the powerful universality of geological processes, the sculpting power of liquids and winds, even when the materials are utterly different. The exploration of Titan is far from over. The success of Cassini-Huygens paved the way for an even more ambitious mission, Dragonfly. Scheduled to launch in the late 2020s, Dragonfly is a revolutionary rotorcraft lander designed to fly from place to place across Titan's surface. Think of it like a large drone capable of traveling dozens of kilometers per flight. Its mission is to explore diverse environments, including potential oases of liquid methane and the rich organic dunes near the equator, searching for prebiotic chemical processes and assessing Titan's habitability. Dragonfly will land near the equator and eventually fly to the Selk Impact Crater, a location where past liquid water may have interacted with organics. It will directly sample Titan's surface materials and atmosphere, giving us an unprecedented close-up view of this hydrocarbon wonderland. So, the next time you see Saturn shining in the night sky, remember the incredible moon hidden within its system. Titan isn't just a frozen ball of ice. It's a dynamic, complex world with rolling dunes, towering ice mountains, a thick atmosphere, rainstorms, rivers, and vast, dark seas shimmering under a hazy orange sky. Seas not of water, but of liquid methane and ethane. It's a place where chemistry we know as gases flows like water, carves valleys, fills basins, and creates landscapes both hauntingly familiar and profoundly alien. It challenges our Earth-centric view of what makes a world active or Earth-like. Titan stands as a testament to the incredible diversity of our solar system, a place that pushes the boundaries of our imagination and compels us to ask, if liquid can flow and weather can shape a landscape with such different ingredients, what other possibilities exist in the cosmos? It's a frigid, hydrocarbon-soaked mirror to our own blue planet, offering glimpses of processes that might be common on countless worlds orbiting distant stars. Thanks for exploring the methane shores of Titan with me today. Stay curious, stay healthy, and keep looking up at Saturn, knowing an alien sea world swirls beneath its rings.